problem definition. One of the major natural disasters are earthquakes, which until this time humanity cannot deal with. It is considered to be the most frightening and destructive phenomena of nature. Earth's seismic activity in recent years is increasing. The largest earthquake of the 20th century occurred on May 22, 1960 off the coast of south-central Chile. More than 2,000 people were killed and 3,000 were injured. The earthquake is so dangerous that we cannot stop it and cannot fight with it effectively. It is impossible to predict with precise date and time, where will the next big earthquake strike. According to latest statistics, new areas of land are covered by this problem, and every year it comes to about 3,000 earthquakes, including more than 20 strong shocks, with the number of victims given in thousands. According to a study, every year thousands of people are killed and hundreds of thousands are injured. In total, over the last 60 years, earthquakes took 1,4 million lives. The result of the earthquakes are most destruction and damage to buildings and land subsidence. Helping people affected by this disaster is particularly difficult because of limited access, limited emergency power, and the absence of any information about the location of victims. We want to change it, using the well-known personal device, smartphone, and our system. Solution and innovation. Introducing the innovative crisis management mobile application code name HELP, which stands for Handheld Earthquake Life Package. Our system helps people affected with natural disasters by identifying and monitoring their medical state and location. HELP is the first mobile system that offers comprehensive assistance to victims of earthquakes. The application uses the built-in inertial sensor devices to detect common crisis threats, collapses, landslides, falls, and fainting. HELP application transforms your ordinary smartphone into life-saving device in case of earthquake or any other landslide. HELP automates the detection of potential earthquakes by analyzing the vibrations of the body, volume, and brightness of the environment. Apart from the smartphone, our system can run on programmable watches equipped with the required sensors. In addition to GPS and GSM, we decided to use a Wi-Fi signal that periodically transmitted serves as a marker leading rescuers to the victim. HELP is using our RFID and NFC and personal database to identify the person and his medical profile to help improve medical services. Software innovation involves the use of all available technology in the device to the location and diagnosis of victims were held in an automated way, even when a victim lost consciousness.
Can you hear me? Tap the screen. Thank you. Can you move? Tap the screen. Thank you. Can you walk? Tap the screen. Thank you.
The system recognizes the user's status by analyzing its interaction with the device and the environment, ambient brightness, sound, and provide timely information to emergency services.
Be careful.
These few simple steps, which will perform a smartphone without the need for user intervention, will significantly reduce the time it takes to find a man in a collapsed building, reduce wait time for emergency services, and thus help to save human lives. Architecture and technology. We have based our application on multi-tier enterprise architecture. It delivers a scalable architecture, which has been tuned according to Windows Azure guidelines. The main and the most innovative part of our solution is a set of mobile applications for Windows Phone 7, 8 and Android smartphones. Mobile applications consist of views and a background service pool, which is responsible for sensor data fusion and communication with HELP server services. Windows Phone platform, due to security reasons, restrict continuous sensor monitoring, therefore HELP implements delayed sensor pulling algorithm. Mobile application contains a set of heuristic algorithms for sensor data fusion, recognizing continuous vibrations of the device in loud environment. All of the device annotated with other information from proximity and light sensors. The communication subsystem is responsible for reporting status to server and other devices in case of emergency with additional text-to-speech service support. When possible threat is detected, the application signals it by periodically sending messages and establishing WIF access point in order to simplify the localization of injured. We have successfully applied MVC pattern and its extension MVVM in form of Silverlight web application. The business logic tier have been developed choosing WCF-based services in addition to infrastructure of available web map services create a SO-based solution. We concentrated on Microsoft technology stack as it has improved team productivity especially, while developing rich internet application solution. Web portal offers basic functionalities aimed at visualization of reported threats. We will extend its functionality to deliver geofencing capabilities which will enable subscription of events occurring in the defined area. At this time, the system has been deployed on the university's resources for locally hosted experiments. Moreover, we already started migration process to Azure cloud environment. Our system integrates also external communication channels such as social media portals, Facebook, Google+, Twitter. We have considered such media as significant for rapid information spreading. Research in field of social networks proves that such evolving structures increase the efficiency of social communication, therefore improve processes of assistance and rescue. Our technology consists of selected combination of complementary data fusion algorithms. Our research shows that combination of selected signals and special questionnaire-like dialogue between application and user can diagnose the injury or a health state.
Thank you. Do you need help? If not, tap the screen.
We have experimented with wireless heart rate sensors as additional source of information for user diagnostic. However, we want to keep the application simple, autonomous. That is why we minimize usage of external sensors. Business viability. Help will be delivered in business model aimed at delivering the application to the people in specific endangered locations. To fulfill that requirements, help will be preloaded by GSM carriers and technology vendors which will install our app initially as a specific platform application. Utilization of open free application stores will offer wider range of possible users. This channel is also dedicated as free unrestricted user access, but in this case supported by the advertisements and product placement. In these models, the income will be generated by the volume of users, which will generate rich application traffic. The third and the most dependent channel of income for the app is financial support by local authorities and NGOs. They will have the opportunity to donate and fund the maintenance of the system. In return, institutions will gain direct access to publish and subscribe channel for immediate notifications about reported and recognized earthquake threats. In time, help will become rich analytical database containing locations and schedule of detected threats. Such knowledge with proper annotations will be offered to our customers as analytical data products.